decentralized authorization. So, without further ado, over to you, Ram.
Thank you.
Please give up Ryan.
I have to say a lot more people than I expected. So maybe thanks to Tanya for finishing her workshop earlier. Thank you. All right, we'll be talking about decentralized authorization, but no blockchain. So the first question is, am I authorized to talk about this topic, right? So in this case, it's subject is me, Ram. The resource we're going to talk about is, in this context, is I work for Pure Storage as a senior security architect, if it means anything. Actions, like I have a book on web services security, co-authored book on ASP.NET Security a while ago. A few other attributes about myself. Yeah, I can speak about role-based access control, fine-grained access control, and any other things around security. So, but the bigger question is, why should we talk about authorization here in this DevSecOps conference? Almost all the talk, but majority of them revolve around finding vulnerabilities, fixing security bugs, running source code analysis on all those topics, right? As security people, we are in the mix between developers, customers, product managers, and everybody. So it's our goal to help the development team to find the answers. Instead of being the team that says, why are you not doing this? Are you doing enough authorization? Instead, you can guide them in the right direction. And just pointing someone in the right direction is enough, because developers are smart enough to go figure out for themselves. So let's talk about what is authorization, right? It's about the subject, user, or an application, or a service, which is trying to access a resource. It can be an API, web application, or anything else. And you're trying to do an action. Action can be read, update, delete, approve, deny, whatever it is. It's about what is the subject is allowed to do, what actions on that particular resource. That's authorization in a nutshell. But then there are different flavors of it. You can talk about role-based access control, fine-grained access control, attribute-based access control, and you can go on and on. So if you talk about role-based access control, it's consonant to this, right? You have a set of users, you assign them to a group, most likely typically an AD group type of thing, and you assign those groups to a role, and then those roles are assigned to resources and action. Right? So this is at a high level how the role-based access control works. And this is what people have been doing for a long time, and it continues to be the case. So if I were to ask any developers here, or if you have said, if I ask any developer to implement role-based access control, most likely, would you agree with this? You would hard code if role equals whatever the role you want for your application, and then if it's there, you're going to return true or false, right? So this would most likely be the case where the authorization rules are hard-coded in the code, and then you make your decision. As the code gets complex, you bury yourself deeper by adding more and more conditions to it. That's how the role-based access control gets started in many applications. So the typical operation is a developer goes and writes their authorization logic, and the security team will say, are you doing the right thing? Do you have enough controls in place? Are you doing the need-to-know basis type of access control? And operation team is left with running those applications, monitoring, and everything else. So what happens is, when a security team goes and reviews those code, we ask the question, can I change those roles? So imagine for a minute that you're buying a product and it has come with some role-based access control in place, and you as a security team goes and say, I want to change what the role means because I don't want to give so much permissions. I don't want manager to approve when the transaction is above a certain limit. So it's because it's your policy, it's because separation of duties, it's because better security control for your organization, right? So when those things happens, the answer is developer would then have to go back and rewrite the code, or if you ask this question in the beginning, they're going to come back and say, I can redesign my role-based access control in a way it is flexible. Now, can I ask the same question to the same developer who raised the hand? How would you redesign your access control where what does the role mean can change after the deployment, after the code is deployed? Any takers? All right, this is one version. I have done this. Instead of hard coding your roles within the code that you're writing, you tend to assign literal strings that are called permissions. So you map a role to a set of permissions, and permissions actually means it's edit something, delete something, create, approve workflow, whatever those actions are. So now we go from roles to resource directly within the code. We have a separation where a role maps to a set of permissions, and then the groups are assigned to the roles. In this case, now we have an answer to the customer or to the security team that says, if you don't like what you have, you can go back and modify what the role means. I've designed this. I've done this before. It's around 2004 I started doing this, and I've done this many times. I'm super excited until we start to deploy this in production. So what happens is when you deploy this in production, this is back in the days. If you remember Julian's keynote this morning, where like 10, 15 years ago, design, develop, test, review, security team comes and stops you from doing it. So in this case where the development is complete, you turn it over to the operations team. They are dealt with adding resources and permissions, creating new roles, mapping what those roles means to the set of permissions. And this is insane because this is where the development and security and operations teams are not working together to solve the problem. If you don't know what this means, you should want to listen to this Ian Coldwater's talk on B-Sides Nova, which is really good presentation that talks about how Dev and SecOps kind of need to work together. So if you're the operations guy, this is what it is, right? Because you've given me pages of information that I have to go back and edit what my access control should look like for every combination of applications, not just for one, 5, 10, 15 applications that are running in my network. So we went from hard-coded to centralized authorization. So the centralized authorization was pushed because when it was individual within the code, nobody knew exactly who has permissions to what. Sarbanes-Oxley came, then you had the vendor pitch came in and said, single sign-on will solve every other problem, web access management will solve every problem. So everybody centralized the authorization, either custom products or homegrown solutions, whatever it is. But the challenge is that if you're building a new application that has to fit into your centralized authorization model, as a developer, you need to understand how do I configure, how is this going to work, how do I design my resources in such a way. I have hierarchy of resources based on your application patterns or web UI patterns, whatever it is. You have to know all of them when you're designing your application. It cannot be, I develop this application, can I go configure access control? No, it doesn't work that way. Now when you want to change policies and permissions, again it gets complicated because when the administrator goes and changes the policy role to a permission, if that's not what you meant in your code is not going to work. If you have not done the hierarchy correct, you're looking at, let's say, manager can view your direct report's salary information, and if the hierarchy is not done right, code is not going to work, but the roles and permissions are done in a different place. And it slows down the time to deploy, time to go live. So hard-coded does not work because every time you need a change, you have to go back and change the code. And the centralized model is not going to work because it's slowing down things. You have to understand how your centralized authorization system works, how you design your service, and everybody is asked to stick to a specific contract as how you design your service, everything. What if you externalize your authorization from the code? Again, I'm not saying you cannot do that with centralized service, you're still doing that in a way. But this is the key difference. Provide the developers with full control over how they can actually write the authorization code. You don't have to dictate. There's no one security team that says, here is my authorization service. These are the 10, 15 parameters you have to pass, and this authorization will do the logic for you, how to enforce the rules. If you pass your parameters correctly, it will work. If you don't, it's not going to work. You don't have to say that, right? So what if we kind of eliminate that, and the developers can write their own authorization rules however you want. And at the same time, once it's deployed, either it is your product that you're deploying for your customers, or your security team comes and looks at it for an internal project, and then they say, oh, this authorization policy either violates separation of duty or compliance or something, they can go back and change it without having anyone rewriting the code again. And it does not involve too much operational overhead. So if you've ever been in a scenario where you configure a bunch of rules and you have to migrate an LDIF file from dev to staging to production, or a script that migrates from one database to another, it's a pain. It doesn't normally go smooth. So, and you get the advantage of time to deploy is faster. It goes along with the team of CI/CD process. Or the buzzword is policy as a code, right? And the other thing is, what if we also give the same thing in a way that the authorization policies are written in a consistent manner? Think of it like, when you look at any database code today, it's all SQL. If you understand what SQL means, you can write code against Oracle, SQL Server, and anything else, right? What if you give them a tool that writes policies in a way it's consistent across any development stack that it's going to work with? So this is what I'm talking about, which is called open policy agent. So for those who have been working in this industry for a while and knows about the pain points of RBAC, fine-grained access control, before OPA became this concept of decentralized authorization, in between there was a concept called XACML, Extensible Access Control Markup Language, which did not go well with the adoption because of lack of open source adoption from vendors. So this is not the first time this is being tried. This was tried before. Yeah. So what is open policy agent? So if you separate out the application logic, that's your business logic, and externalize your authorization into a separate service. That's in a nutshell what OPA does. So the service receives your request, it enforces the policy, executes your authorization logic, and these policy files are outside of your code, which means I can go back and modify what the authorization policy is after the development is done, after the deployment is done, because there is a compliance violation or you found out that you given more permissions. It's written in Rego. Rego, if I recollect, it came from Datadog. It's a query language. The way I equate Rego in the open policy agent context is it's like SQL for your databases. So when you learn Rego, you're actually learning a language where you can write authorization rules across many applications in a consistent way. So here is a very brief example, like copied from the OPA website. The semantics are very simple, right? You just write a package, you have your input, which is either hard-coded here, or you can refer to the data file outside. And this is the main block where you're just saying, here is the method I'm going to write. As long as it matches the condition that the input method equals get, the path that you're trying to access is one of this path, and the username matches, then you allow the user to gain access. So this is all written. Once it's written, it's actually made available for you as an HTTP API. It's, from a developer's context, it's all API interactions. What is the other benefit you get with OPA? OPA as a framework can actually provide you the decision logs. So if you were to write your own centralized authorization service, you have to write the framework to log all the allow and deny decisions and everything else. So OPA as a framework provides the webhook. You can write and it can go to Splunk or any other system that you're using. It has an option to, it has a telemetry service. You can go watch whether the service is up and down. The policy files I'm talking about, like these can be individual files. It can be, you can bundle all of them into one bundle, like a tar file, and that can be distributed. So that means the OPA runs, it has an option of looking up, is there a new policy file available? It goes and downloads the policy every 5, 10, 15 minutes. So now you have an option where as a developer writes the new code, deploys them, the policies can be updated without having to go and configure authorization in a separate system. So let's look at it from a developer standpoint. What does an OPA look like? It might look like, well, it's a new language, it's something static. Once you return your regular policy, all it does is, I'm using an API service as an example. So you have an API client that is invoking a regular HTTP API. So now when you invoke an API, everybody who has written API and authorization before have done this, either Spring Framework or custom HTTP filters. You've written this where you look at the incoming payload or headers, and based on that you make decisions. Either you write a library, shared library. So in this case you can write a filter, or it can be in the Kubernetes world, it can be an S2 proxy. Or any other proxy, Unix proxy, internal your HTTP API. It intercepts it. It makes an HTTP call to the OPA service, passing the inputs as JSON. The input can be, here is the resource somebody's trying to access, here is the username, here is the action, just get posted. And you can send any other payload that is part of your HTTP request. And that's it. That's all the developer has to know. Now, since they know the business logic better, they know they are closer to the product, they can write the authorization rules external to the code, same as they used to write before, which is hard-coded. They can now do simple role-based access control, fine-grained access control, however they want. It's per business logic, per department. It's very externalized to the code. And it returns back an yes or no. You can also return back additional data for you to make other choices. And then that's it. Then you access the API endpoint. It's completely transparent. So now, if you have an externalized policy, your application logic is basically saying, okay, I'm going to use the plugins to invoke my external policy service, and that's it. It gives me a yes or no. The policy service can be, the policy files can be updated independent of your application code, right? So the policy file gets updated on a daily basis or weekly basis, whatever, based on how you want to fine-tune your authorization mechanisms. And that does not affect your code at all right now. Again, I want to kind of relate this back to, like, is this concept completely new? No, the concept is not new at all. The only thing new is about writing your authorization rules in Rego, and the open policy agent as a framework has some of the built-in decision API and other thing to make it available easily. If you're familiar with Kubernetes authorization model, I've referred to this in a couple of other talks. The Kubernetes authorization model, when you look at it, it comes with a default role-based access control. It has extensions for doing your own attribute-based access control. But the best thing is it has a webhook that's if you don't like role-based access control, if you don't want to follow our attribute-based, invoke this webhook. That's it. So every API will invoke this webhook. The webhook is yours. You can write this in Python, Java, whatever you want. That API can do all the authorizations. Right now, you can do custom authorizations with your own language that you're familiar with, or you can use OPA. The authorization model is externalized. That's the best thing about the Kubernetes model. On the Kubernetes topic and OPA, recently I came across there's a gatekeeper available, which is written in OPA that has built-in access controls type of thing in place, like whatever policies you want, you can enforce it. I haven't looked at this in detail, but it's basically contributed between, I believe, Microsoft, Google, and the people of the OPA community. That's at the high level. So if you had to do, the key takeaway from this would be is, let's externalize authorization from the code, keep it outside of it, and so that way the policies can change without having to rewrite the code. And if you can use OPA, I think HashiCorp also has its own authorized policy as a code type of thing. So whatever you want to choose, standardize across your development platforms. And the better thing is when you have an externalized service, you want to know who is allowed, who is denied, because that is a security metrics for your security operations team. You can integrate with any security incident management tool, like Splunk or other things you have. And if you establish a pattern for something that you're building, and also if you start asking the same question from the vendor that you're buying, then from within your enterprise, if you look at it, your authorization looks the same, no matter whether it's a homegrown product or a third-party product that you're buying. So the authorization in OPA is relatively new, right? I have the saying, encryption without authorization is completely meaningless, right? So if you look at any data at rest, database encryption products, if it's natively encrypting, if you're not doing authorization, everybody's going to get the data out. So encryption without authorization is meaningless. So same thing, and authorization without strong identity, strong authentication is also going to be meaningless. If everybody's using the same username and password, it doesn't make any sense. As we go into serverless, Kubernetes type of deployments, you want to look at how do you get identities, how this your service is authenticated. So one thing to look at is Spiffy and Spire in the same context. They're both part of the Cloud Native Foundation. You may want to take a look at that. That's it. Any questions? Axiomatics was based on Zachmal before, unless they changed something in between. Yeah. Yeah. So I was referring to this. So Axiomatics, I believe the person who runs there's a person there. He came from Burton Group. Burton Group acquired by Gartner, I believe. They were the identity management experts a while ago. Zachmal was the OASIS standard for access control. The approach was that we define an XML schema, and you have the policy is defined in XML, and every policy enforcement point that every application or API service, they would understand what the XML looks like, and they would implement this. The challenge with that approach was there was no open source adoption. The plugins were not that available. And there were a couple of commercial vendors selling this product. And it was very hard it was security centric. As a security person, you can understand what it is if you spend the time. Developers typically don't have the time to go back and learn about these things that are not impacting their business. So I was a developer at the time looking at security stuff, so that's why I paid attention, and then I said, okay, this is too much to do. I go away with that. Yeah. So yeah, there's nothing to blame the product or anything. I've not used their commercial product, but the standards, it was based on the Zachmal standard approach. I believe they have a similar version of it. If I haven't looked at it recently, they have a similar team as the Open Policy Agent right now to do the same thing. It's not using Zachmal, it's something else. They were trying to push it through the standards committee, if I'm not wrong.
Hello?
Yeah.
Thank you for the talk. So you spoke about moving the authorization to an external service or external part of the code base. So once that happens, what are your guidelines for making sure that there's full test coverage? Because once you remove the authorization logic from the code base itself, like the unit test as such would not catch it.
So the decisions API from Open Policy Agent in this case gives you the coverage of which methods are getting. So if you return you can think of them as unit test cases. If you have 5 different allow conditions and deny conditions, you can make sure that every endpoint goes through. So if you have 10 API endpoints, you can run through your test case and look at the decision log and then say, did all this 10 go through the condition? And then I get an S, and you can go through the misuse case test cases and then look at the decision API and say, did I get a deny for these misuse cases? So that's one approach to look at. Yeah.
So as a follow-up, in addition to this approach, once a lot of your logic is put into this configuration-like approach, should you also be verifying in the production environment after the ops people have touched it?
Yes, so the production environment, you want to make sure that the policies are deployed in a controlled fashion. And once it's deployed, you want to be monitoring for whether the right person is allowed to access it. That's what I was talking about. If you design in such a way that this problem is the same whether you use policy or not, where you send the decision logs to Splunk and you're monitoring this in your security incident management tool. How many allows I'm getting, or are you getting a strong number of denies? Those are your indicators.
Great, thank you.
How does OPA fit in with OAuth?
That's a great question.
And then,
Okay.
could I ask 2 questions?
Sure.
And then with the OPA, can you do more complex
Yeah.
methodologies like risk adaptable access control, something like that?
You can do, it's very open in the sense you can write whatever authorization framework you want to write. It can be simple role-based access control. You can make external API calls. So if you're on risk-based access control, you can make an external call to get out the attributes I have and let the third-party system define, is this a high-risk transaction or not? And then you can say yes or no based on that. So that is definitely possible. And your first question on OAuth versus OPA. So OAuth was, in some cases, it was initially written for end-user, consumer-facing application, right? So you were actually granting access. You're saying, okay, I will allow my name and email address to be shared with Google or Facebook, type of thing. What people started doing was I started exposing this for enterprise use cases. So now, when you're building enterprise B2B use cases, when you go to a payroll system, you don't grant access saying, yes, I want my payroll to go to this bank on a daily basis. Because it's your contract between your company and the payroll company, right? As people started exposing enterprise APIs with OPA, with OAuth authorization model, the scope creeps, the number of scopes increases. Now, if you're a developer trying to write something against a particular API, or if you're a developer exposing API and giving customers the control, you have to tell them what are all the different scopes available. And you have to internally map what the scope means to a resource endpoint. So, so that's going to be the problem. So in this case, what you can do is you can kind of leverage, you can still go through an OpenID Connect flow and get a JAR token, and you can pass the JAR token to an OPA authorization service here, and then say, is this a valid service or not? Now, if you're externalizing this, so you have the same semantics of which role, with the role-based access control, customer can come in with a particular user and role to access your service. You can even give the customers a complete control and say, here is an endpoint that you can configure. And they can start up an OPA service and they can enforce all the rules. They don't have to understand your meaning of which scope maps to which resources. Instead, they can say, okay, these are all the 10 API endpoints I'm going to invoke. Let me figure out who can access those API, and I will stand up an OPA endpoint. But again, the threat vector changes in this case because you have a B2B where your third-party service has an OPA endpoint. But it's definitely something to be talked about more. Yeah. Thank you.
You may have answered this already, so sorry if I'm repeating application that sit behind the agent need to know the identity of who is contacting them, but also which roles, which permission they have. So how do you pass that information down to the application? Do you put that into some sort of header?
Yeah, so kind of answering a little bit to the previous question. So the application first receives the request. It's receiving through the end user-based web application. That problem is the same whether you use OPA or not, where your end user goes through an OpenID Connect type of flow. You have a JOT token available, right? Now you're making REST API calls and you're passing the JOT token in the header. Now the REST API level, when you're invoking REST API, you have the either the JOT token or any other semantics, either it is mutual TLS, your certificate information. You have those information available in the header. And your filter basically grabs those information and then passes on to OPA and then say, here is the information available, either a JOT token or the actual user and role. And then it's up to the policy you write to say whether you want to allow or deny.